All right. In the last video, we looked at kind of organizing our code a little bit. Oh, here we go. By using our .h and .c files in a similar way to similar manner to the way that we use them when we're working with CPP files or in C++. What I want to do today is just kind of close the loop on some of the functions that we talked about. Specifically, we created a function called compare, anticipating that we might want to sort a list or an array filled with these dog structs. So we have this compare function that we actually did define in the dog.c file, and so now we're going to put it to use within our main.c file. So what I want to do is right here, between getting dogs and printing the dogs, I'd like to sort them. And I'm going to do this using the qsort function that's provided with the standard lib. And again, so if you're looking in c++.com and you see a C standard lib, then you can almost certainly guess that if you just put standardlib.h in your C program, that you'll get what you want. So this is just kind of their C++ branding of these old C libraries. So qsort, let's take a look at the declaration for this function. So it doesn't return anything. And we see that it takes an argument of a void pointer for a base. And a void pointer, what's that mean? Well, void, we think it means nothing. If it's a void pointer, I should have probably specified this earlier, but we're dealing with a pointer of no type. So it's going to be an address, but we're not saying anything about the kind of data that's there. This is very useful, very powerful. It's also very dangerous because this is a way to circumvent the type system in the C programming language, which kind of defeats the purpose of a type system. So we want to do this very sparingly, but where it's needed, it's actually quite powerful. So in this case, qsort can accept a pointer of any kind because we said it's just a pointer. We don't know anything about its type. Now, we can get away with that if we give the appropriate information to qsort for it to figure out the rest of what it needs to do. So specifically, it needs to know size t num. You can think of size t as an unsigned int at this point. This is going to be the number of things that this is pointing at. And then size t size, which, if we look down here, is the size in bytes of each element in the array. So it needs to know how big the array is. It needs to know where things live so that it can move them around. Now, in order for quicksort to work, it needs to be able to compare the elements in those different positions to each other. And that's where the compare function we wrote comes in. We need to provide this last thing, this compare argument right here. This is going to be, where we go, okay, a function pointer. And this needs to be a function that compares two elements. And that's what ours does, okay? And it does know about the type that is being sent into qsort, and so it's able to appropriately compare them and then tell qsort all it needs to know, which is, hey, the element at position 0 and position 1, they need to be swapped because they're in the wrong order. That kind of thing. And then it can move the bits around. It doesn't need to be able to read them any more than that. So let's use qsort. So again, we'll give the base, which is just a pointer to the top of the array or the base of the array, however you'd like to think of it, the number of elements, and then the size of those things, and then finally the pointer to our compare function. So let's see if we can make this work. So we've already included standard lib, so we can say qsort, and we need to give the base of the array. We need to say how many of them there are, and we need to give the size of each of them. So we'll use size of yet again. Okay, and then we need to provide this this compare function that we want to use. And actually, we can just use its name. Compare dogs. We double check that. Yep, that's what we called it. And the compiler will now know that, oh, you're referring to the function, so I'll use the address of that function and I'll stick it right there when you try to call qsort. And there we go. That should be enough for qsort to execute and sort the dogs that we give it. let's try and build this. I promise I hit escape. Just didn't respond. Okay, there we go. All right. Control Z will make this. Oh, compare dogs. Did you mean some dogs? No, I didn't mean some dogs. Let's take a closer look here. Compare dogs. Oh, that's correct so far. We definitely did some dogs there. Oh, I know what I need to do. Excellent. Okay. Even though, well, no, that should work. Did I spell that wrong? Give me just a moment here. Ah, that's what's wrong. Notice here we called this compare. It should be compare dogs. Be more explicit with that. That means we're also going to need to change that. Oh, we did call it compare dogs here. Okay, so now our definition and our declaration line up. Now you'll notice we didn't have any compiler errors before. Why is that? Well, we weren't trying to use that function. So even though we declared it but never defined it, we never ran into any trouble because the compiler at no point had defined the function for a function call anywhere. So we ran into the problem here because we finally uncovered that we declared compare, but we didn't define it. We defined compare dogs, but we had not declared it. And so in our main.c file, the compiler didn't know anything about compare dogs because even though it had seen compare in dog.h, that didn't line up. So hopefully that makes some sense. This should fix the problem. Make again. That's promising. Sort dogs. We'll go with 3 dogs this time. Let's see. So we'll use Pepper again, and we'll make her old. Okay, so she's going to be 12 years old, and she's eaten well during those 12 years. We'll say she weighs 50 pounds. And then we'll create Dog Buster. And we'll say he's only 5 years old and 15 pounds. And we'll do one more. We'll call him Lightning. All right, so Lightning is actually going to be, we'll say 7 years old and 20 pounds. Now, this should be sorted, and then the results should be printed to the screen. So there we see Buster, who's 15 pounds, he's 5 years old. Lightning, who's 20 pounds, 7 years old. And Pepper, who is 50 pounds, is 12 years old. And we see that indeed they are listed in ascending order of age, which is exactly what we wanted. All right. Well, I'm going to call that a success for this video and leave it there. Until next time.